Okay, I'm going to do this the right way now. The idea is that I'm going to use Bolt to create an equivalent enemy AI graph. I guess it's a little tricky to do this on kind of a single display. So I will give it my best shot. We'll see what goes on here. All right, so in the game, you'll notice I have a bunch of enemy AIs now, NPCs, and let's see. Also, let's see, turn on the lights there. There's the normal, there's two varieties over here already, varieties, a whole bunch of different ones. And there's these over here, these sort of docile ones that don't attack, thankfully. But if I get close to them, or if they are sort of within, if I'm aligned with them, well, what should happen is they should start to follow me if I've upright. Perhaps I haven't. I don't know. What's the problem? They're not really following. Okay. Let's see if we can't fix that. Here's our little AIs, and they are here, these new NPCs. And, okay, the problem is that neither state machine or flow machine is turned on. So let's turn on a state machine. Or, well, let's turn on a flow machine first. All right, so if I hit play now, try it again, and we'll jump to the game, turn on that as a single graph. So this is sort of like just creating a traditional class for a enemy AI, and there's sort of two parts here. Again, it's a little bit tricky because there's a lot going on in Bolt. And hero's position, you'll see in here or somewhere, I'm finding the game object called hero, and I'm assigning a variable called engaged or not. So if I'm engaged in following the hero, and in order to figure that out, I'm saying, well, get the position of the hero, subtract that from the NPC to the player. What direction would that be? And then I use that direction to compare to the kind of current motion or orientation, which is the velocity vector of our NPC. Right? This is here's I'm using a get on the velocity of the rigid body, normalizing that to get the direction that it's moving in, and I get the direction it would need to be in if it was facing the player, for example. And then I take the dot product of those two to figure out how closely that orientation and the ideal target would be. And I compare that, see, okay, is it within, basically, is it on the same side origin, pointing in the direction of the player, using a layer mask that is everything but the NPCs, not null. That's what's going on here. So its program is continuing to flow. If not null, then I set this engaged or not engaged if and only if object that I'm hitting, does it equal hero? If so, yes, I should be engaged. I should be pursuing the player. And what do I do when I'm pursuing the player? Well, that happens up here where I have this. And it's easy to turn a custom event into a coroutine. Right? So if you click here, and if I had the graph, let's see. Well, if I had this as a pop-out window, it's easier to do. Wow, look at that. Let's see. Shrink that a little bit and pop out this flow graph. And if I choose this custom event, it is a coroutine, right? And because it's a coroutine, I can use this wait, for example. So the wait 4 seconds, right? That's something that we've seen in coroutines. So, yeah, I can do a full screen. I can't shrink it here, unfortunately. Okay, well, we'll just close it. Machine, which is a macro, which basically means it is a sort of a script that we can use over and over. And it's called Simple AI Flow. Open it up again. There it is. Okay, so this part here, we say, okay, the custom event gets triggered. All right, so while what is it? While true, this is what this is up here. While, so this gets triggered. Here's the condition. And the body of the loop is everything that gets point to after this. So this have a delay, And then I flow through here. I make a decision. Am I engaged or not? If I'm engaged, I do this, which is I just set the velocity in the direction of the player, the direction that points from the enemy to the player, the NPC to the player, according to some speed, right? I scale it according to speed in here. And if it's not engaged, instead, so if it's false, I wind up just creating a random vector and adding that as a force over here, right? So I choose a random x and random y between -5 and 5, and I continue on. And then, of course, when the rest of my loop here, right? My check to see, is it engaged, right? So every time I move, I then check, okay, am I engaged? Or should I be engaged? Should I notice the player? So that's the one way of doing it. This is as a single flow graph. Now, the other way is probably the more sophisticated way, probably the more interesting way, which is to use a state machine as opposed to this flow machine. Now, state machines are interesting because they have states, right? So this is what our state machine looks like. And we have sort of two states, and I should really change the title of that one to pursuing. And this one here, it's the start state. I can't change. Can I change the name of it? Well, I guess I can. Wandering. Okay, so I've got the wandering state and the pursuing state. All right. Now, if I right-click on here, you can see I can toggle the start. And so this is going to be the one that we start in. But this state machine is interesting because we have another state here, which is our check for pursuit. Okay, so this is always checking for pursuit, and this happens immediately as well. So we have two sort of initial states, which is weird because normally state machines, you think of them as being in one state or another. But we have two starting states, and the important one here, well, we can look at either of them. All right, let's look at wandering. So wandering is, again, it's a coroutine, but this one, all it does is the wandering piece. It's okay, while true, randomly 1 to 3 seconds, we wait 1 to 3 seconds, and then we add a random vector to the rigid body, the force, right? So this is the one wandering version. Every 1 to 3 seconds, we add a force to the NPC. Just pokes it around in some direction, right? Now, the other state is the more interesting state. Now, this is the one where we say, okay, we find, this happens in the update here. I thought I had changed this, but anyway, this will work. In the update, we will find the hero, right? We find the hero and get its position, and we take the position of the current, which gives us the direction from the NPC to the player, right? That's what we get when we subtract the two vectors. We normalize that to get a direction. We multiply that times 3 to speed it up. And this is, we're setting the velocity. So that's why the update rate doesn't really matter. We're just going to set an instantaneous velocity, which is going to be saying, okay, the NPC should be moving to the player at that velocity, right? So that's what's happening. We find the player, we use its position and the NPC's position. We subtract the two to get the direction from the NPC to the player. Normalize that, so it just becomes a pure direction. Multiply that by 3, so that's a reasonable velocity for the NPC to be moving at. And we just say, all right, that's the new velocity for the NPC. And that's what happens in the update routine, right? So here, as long as we're in the pursuing state, that's what we're going to do. Set the velocity to move the NPC towards the player. And the wandering state, we add a force in a random direction, right? So we're either pursuing, chasing the player, or wandering, which is just random force every so often. And then we have something that governs the transition between these two states. Notice this one has an arrow this way. It says, oh, okay, if what? If pursuing, we get the pursuing variable, which is a Boolean. We say, okay, get the pursuing variable. If it is true, we want to transition. And so here we are transitioning, notice, we are transitioning from wandering to pursuing, right? So if pursuing is true, it causes this transition. And this is the opposite. Okay, we have an update, and it's checking during the update routine to say, okay, is pursuing false? If it is, trigger the transition. Okay, so we have those two transitions, and we have these two states. And now we just need to say, okay, let's check. We have some code running. This is more or less a flow graph here inside here. It looks just like a flow graph, which is the decision making. It doesn't really make the decision. It just sets it up. It just sets up the pursuing variable, right? So this happens at some rate. It's going to say, okay, we have a start. And on start, we grab the hero, because that's what we're interested in figuring out. Are we facing him? Do we have a clear shot? And so on. So we find the hero. We save it as the target. All right. So this happens once. And then we have a infinite while loop. So this, again, this winds up being a coroutine. All right. So we find the hero. We set it to a target. So we just have a local version. So we're not doing find over and over and over again here in our while loop. And then we have our infinite loop, infinite coroutine here, which actually, first thing it does is it delays for 0.2 seconds. So we do this every 5 times per second. Okay, that's what the body of this loop is going to be executed 5 times per second. All right, that's this flow through here. All right, and the first thing we do in the coroutine is we set pursuing to false. We assume that we're not in the pursuing state, that we can't see the player. So let's check everything that would say, all right, can we see the player? All right, so we continue on through here, and we are going to change that only if, right? So we've set pursuit to false, and we're going to set pursuing to true. Only we're only going to like process this if some things are also true. And what are those things? Well, we get the current direction, the velocity of the player. We normalize it. Excuse me, this isn't the player. This is the velocity of the NPC. We normalize that. So we now have the direction of the NPC. And we take a dot product between the direction of that NPC and this is our direction of the player. You might recognize this from somewhere else. Now we're using this target. We're getting the position of the target. We're subtracting it from ourself, right? That gives us a vector that's in between the target and the player, or the player and the NPC, or the target and the NPC. Normalize that to turn that into a direction. So we have 2 directions. We have 2 vectors, right? Take the dot product. If they're greater than 0, we know they generally face in the same direction, which is good. Okay, so we're saying, okay, now continue. Turn that true so that this will continue processing here. All right, so that's true. So processing will flow through here, this true. Now, okay, if it flows through, now it's going to trigger a bit more processing. It's going to say, okay, in order to satisfy this, to go from here to here, we have to pull some other information, all right? Once again, we're going to get our current position. That's going to be the place we start our raycast from. All right, so we're going to cast a ray. The origin of the ray is the NPC's position, and the direction that the ray is going to be cast is this direction that points from the NPC to the player. I'll move this. I'm just kneading it up as we go. All right, this is the direction from the NPC to the player. So I use that, normalized, that is the direction. The origin is the NPC. The distance, we just set to 10. So we say, okay, we fire, this is basically casting a ray that is length 10 from the NPC toward the player. The mask that we're interested in is, of course, everything except for the NPC layer so that we don't have the NPC point at itself or any other NPCs. This will give us some kind of result here, this raycast, right? It will wind up giving us a collider. This is the raycast hit, right? And we're going to get the collider of the raycast hit. See, did it collide with anything? And one thing we want to do, of course, is we also want to check, did it not collide with anything? So it didn't collide with anything, we don't want to do having hit something. So if it doesn't hit something, so process is going through here now, we've potentially filled this information in. So a process came over to here. We said, okay, if it's not null, we're going to process. Okay, so we have this, we know, is it null or not null? If it's not null, we know that's good. So we're going to continue processing. And what we're going to do is we're going to potentially set pursuing to some value. We don't know if that's true or false yet, but what it's going to be, true or false, is depending on here, we're going to use that result of this raycast to get this game object, to get the name of the game object. So the thing we collided with, what is its name? Is its name equal to this literal string, which is the hero? So if the thing we hit is the hero, we set pursuing to be the result of that, which is true or false. Okay, so if it wasn't the hero, if it was a wall, this would be false, and we would set pursuing to false, right? But this is important over here, this not null check, right? Because if you try getting the name of a null object, this will be an error, right? So you don't want this to draw all this stuff up into here, right? For this to be activated, to be processed, if this was null. So that's why we kind of stop execution here if it's not null, right? So that's everything that went on here. Now this is going to happen every update, or well, it's going to be, all right, so that's what's happening in this one. So if we go back up again, we look at new NPC. So this is happening every 1/5 of a second. It's going to check, are we pursuing? Or it's going to generate this pursuit variable. And then these two transitions are going to check that variable to decide which of these two states should it be in. All right. So the end result, if we, we had turned on the state machine. There. You'll see the NPC is seeing me and sort of following me around here. I sneak around really fast enough, or if I kind of throw a coin at it, push it in the opposite direction. So now it's going to assume, okay, you're moving in the opposite direction. So therefore, you can't see me. Oh, it's really going fast. Whoops. Should have done that to that poor squirrel. Let's see. Ah, okay. Yep. So we have some pursuit going on here. Squirrel and our NPC are pursuing. Now, if I run up in here, okay, they both stopped seeing me because of the collider there. Push everybody out there. Oh, okay, the squirrel noticed me. So on. We have our bolt-based NPC. Let's see if we can't see sort of the logic being executed, just for the fun of it. All right, so we'll say game. We won't maximize on play. And we will split the screen here. There we go. And so we'll look at this one that's chasing us. And we'll look at the state machine. If we can see that going on. All right, so we see this churning away to see, generating that pursuit value here. All right, let's see. So pursuing, it is pursuing right now. If we were to push her away, let's see. Pursuing has gone to false, right? We're not even, oh, we're pursuing. Are we pursuing again? Nope. It was potentially pursuing, but we must be blocked by something, right? That's the interesting part. Let's see, we're, oh, now we're not blocked anymore. There, pursuing. So it's a little bit tricky. Debugging can be a little bit tricky, and kind of seeing what's going on can be a little bit tricky in Bolt. But it is pretty cool that you can sort of reason through it and kind of visually see what's going on in the graph there. So if you have never use Bolt. Now's a good time because Bolt is now a free asset in the asset store, and it's pretty powerful. Certainly things like blueprints, sort of, and also visual programming inside of Godot. So it's kind of evening out or leveling the play field between and Unity. All right. Hopefully that helped with some things. I'm Eraser Mice, aka Dr. Eric.